Welcome to VK's Coding. So in this video, we'll talk about message queue. But before getting started with the message queue, let's first understand what is the problem and what message queues are going to solve it. So let's see, we have a two service here, service A and service B. If service A want to communicate to service B, it can be use a two approach. First one is a synchronous request reply. It means service A requesting to the service B and it is giving a response back to the service A. Then it is fine, right? And what happens in the synchronous way? Service A is calling to service B. Even service B is taking, suppose, 1 minute of time for executing that particular request, and then it will reply back to the service A. But it is getting a response, right? So there is no problem. Request response is getting delivered, right? So it is working. And how the asynchronous communication works? So basically, service A send a request to service B, and even the service B takes time 1 minute for execution, but it will immediately return some ID. From that ID, service A will keep on calling and getting to know the status, and once it is able to successfully execute the service B, it will get the response back, right? That's how asynchronous REST works. So there is no problem, right? We are requesting and we are getting a response even quickly, or even it is after getting delayed of some time, but still we can poll and get the response, right? But let's talk about the another scenario here. Suppose service A call to service B and service B goes down and service A doesn't know what happens to that particular request, and it waiting state, right? It doesn't know. So even if you do rest synchronous way, you won't get a ID back, right? And even you do in a synchronous way, you are waiting, you are holding thread and waiting the response from the service B, but you are not getting any response. So this is the first problem. And what is the second problem? Suppose service A is requesting to service B and service B started execution, and in the middle of the way it got crashed. Again service A will not get to know what happened, and there could be a mini problem, power outage, service down, anything can happen. Even there could be no response back sent to the service A, or it could be delayed in processing, right? And the service A could time out, right? And again it will send a request. It's kind of a duplicate request, and again we have to make a item potency API implementation in the service B. So there will be overhead on the service B side, right? So this is the second problem. And what is the third problem? So in third problem, suppose there are many services, right? Service A, we have a mini instance which is requesting to the service B, and they are like calling anything like that to service B, and service B is getting so many requests from the multiple instance of the service B. Then what happens to the service B? Service B is eventually not able to handle the load, and it will crash again because there are the too many requests to be handled by the service B, and service B will be not be able to handle that. And how we can get those many requests? Suppose you are getting the details from IoT devices or from monitoring system. Even if you see the Ola, Uber applications, right? Drivers keep on updating their status to the applications, right? Every 30 seconds, it will update their location, longitude and latitude to their servers to get to know where the exactly the cabs are residing. When you search the cab, the app will find out the radius, which are the cabs are present in the your particular location. So these are the problems, right? These are the three problems we are facing currently, and this could be solved by using the message queues. So what is message queue? So it's a kind of a middleman or a message broker which use a message queue to store the messages. Basically, if the service A want to send the message to the service B, service A will push the message to the message queue here, and service B will subscribe to this message queue, and it will get the message from the queue itself, or it can poll the message queue and get the message. And these are asynchronous in nature as well. What you can do, service A can push the message and it can continue with the other task. So it's kind of a fire the message and forget about that message. It will be handled by the message queues or the message brokers, and it will be eventually consumed by the service B. Also benefit we are getting here, suppose this service B is goes down, so that message will be still persisted in the message queue, and whenever the service B will connect to this particular message queue again, then the message will be delivered to the service B, or service B can poll the message, is there any message left for me? Then he can read the message from the message queue. So that's how we'll resolve the second problem. And the third problem, suppose lot of services are pushing the so many requests, right? Service B is not able to process in very fast, right? It takes time to process it. But these messages from the different instances of the service A can push those request messages in the message queue, and the service B can take those messages, right? Eventually, however, it can process it one by one, their own pace. Matching the pace, right? That problem will be also solved by the message queue here. And there is a retry mechanism also will get the benefit from the message queue itself. So what happens, suppose one message is delivered to the service B and it respond back processing is failed, right? Then the second time also the message will be sent again, second time retry, and its reply again the message is failed. Then again third time message also will be sent to the service B. So that's how the retry mechanism also be there for the message broker, which will deliver the messages to the service B. So these are the benefits we'll get the using the message queues. So let's first talk about the RabbitMQ. So there will be a producer. So I have defined here the producer. So who is the producer? The application that sent the message will be the producer, and the consumer. Who is consumer? The application. Here I have defined the consumer which will receive the message, right, from producer. And what is queue? Queue is nothing but which will store the messages. So I have defined here three queues. Q1 and the message. What is the message? So message I have defined here the information that is sent via producer to the consumer. And again we have one more component here, that is exchange. Basically exchange will receive the message from the producer. So there will be a rule defined in the exchange. According to that it will transfer that message to the one of the queues, and from that queue the message will be consumed by the consumers, right? So next we have a binding. Binding is nothing but there is a link between exchange to the queue, that is nothing but a binding. So next is the routing key, the key that exchange looks up and decide the queue to route the message. Basically in the message itself routing key is defined, and the exchange will look at that particular routing key and route that particular message to the queue. So now let's see one flow how the producer pushes the message to the broker, how the consumer will receive from the message from the broker. And the broker is nothing but here is the RabbitMQ. So let's check one flow. So suppose we producer produces one message and having a routing key one, then when the exchange is connected to the queue there will be a binding, and binding is nothing but the link between the exchange to the queue, and there will be a binding key is defined for each queue connected to the exchange. So I have defined here the binding key 1 for first queue, second for second queue, 3 for third queue. Now when the message arrive from the producer, it is having the routing key 1. So first the message will received by the exchange, and exchange will compare the routing key with the binding key. So both are matching 1 1. Then this message will be pushed to the Q1, and from the Q1 the message will be pushed to the consumer. So basically consumer will subscribe to the queue, and from the queue that message will be pushed for the consumer. So this is how the message is routed from the producer to the consumer. Basically exchange will look up at the routing key whatever defined in the message, and it will match with the binding key, and it will put that message into the particular key which is the binding key is matching, and from that queue the consumer will consume that message. This is how the flow will work. Next we have a different type of exchange. So in exchange the first type is having a direct. So in this what will happen, the message will be delivered to the queue based on the direct routing key. So what happens? So binding key is defined 1, 2, 3, and there will be a routing key defined for that message. So producer when this pass this message to the exchange, exchange will match that routing key with the binding key, and whoever matches with the binding key, the message will be pushed to that queue. So exchange will check the routing key and match with the binding key, and then it will push that message to the relevant queue which is matching the binding key, and from that queue the consumer will consume the message. So this is the first one with the direct exchange. Second one we have a fan out. So in the fan out exchange the message will be pushed to all the queue connected to that fan out exchange, and from that queue the consumer will consume the message. So this is the second type of exchange. Now we have a third type of exchange. There is a topic exchange. So this is nothing but a wildcard matching will be done for the routing key against the binding. Suppose the binding is defined as 1 2 star, 3 4 star, 5 6 star, and the routing is coming as 1 2 3, then the exchange will match the binding key against the routing key. So here the 1 2 star will match because 1 2 star means any letter or character will come after 1 or 2, that will be matched, right? So this match will be pushed to the first queue, Q1. These are the Q2, this is Q3. So here this message will be pushed to the Q1, and from the Q1 the consumer will consume the message. So now let's talk about RabbitMQ retry mechanism. So basically, client declare whether to use the auto acknowledgement or not while consuming the message. So basically, in the auto acknowledgement means the broker can discard the message when it's delivered to the consumer. Means even the consumer has not processed that message. And the second one, we have a manual acknowledgement. Means the broker should wait for the consumer to explicitly acknowledge the message. While when the processing is complete by the consumer, then it can notify the broker the message is successfully read, like that. And after that the message broker can delete that particular message, and it can also reply the negative reply. Suppose the processing it fail, it can also reply negative to the broker, so the broker can deliver the message again. Actually, what is happening here, suppose one message comes to the routing key 1 here, right, and it is a binding key 1 is defined, so this message will be pushed here in the first queue. So there is a Q1, Q2, Q3. So this will be pushed to the Q1, and this message will be delivered to the consumer one. And when the consumer started the processing, it got failed, right? It can reply that to the consumer read failed, and we can define the number of retries. So suppose the number of retry is here is 3. So the message will be pushed again, right? Second time, and again it start processing and it's failed. Then again the message will be pushed to the consumer third time, and if again it is failed, now retry is completed. Then what happens to the next, we can configure the dead letter queue as well. So the message which is retry has failed, that can be transferred to the dead letter queue. So that message will be transferred to the dead letter queue. So this is how it gonna works. If the retry will fail, then those messages will be moved to the dead letter. And this RabbitMQ is kind of a push based mechanism. So basically the message will be pushed from queue to the consumer, and this is how the retry will work, the manual acknowledgement. So next we have, let's talk about the Kafka. So in the Apache Kafka, there will be a Kafka server. Basically, it is a kind of a one machine, let's say node 1, which is running a Kafka server, and it will have multiple topics. So topics is a kind of a different type of data stream, or it's a kind of a logical grouping of the partition. Like one topic will store the driver data, second topic will store the client data, like that. Different topics will have inside the one Kafka server. Inside each topic will have a different partitions. Basically the partition with the message will be stored in the partition. And we have a offset in the partition, all the messages, and to keep track those messages, offset will be used. So these are the numbering in the partition. 0 1 2 3 4 are the offset. And we know the producer, the client application which pushes the messages to the Kafka server, right? And this node 1 which is running the Kafka server, right? So that is nothing called a broker. And next we have a consumer. So basically this consumer will subscribe to the topic, so it can read the messages from the partitions. And group of consumer is called a consumer group. So this is overall about the different component of the Apache Kafka. So one consumer group can read the messages from the one topics, and each consumer group will read the messages from the different partition. So suppose we have a two consumer here, consumer one, and so both will read the messages from the same topic but with the different partitions. And from different consumer group, suppose consumer group 2 is there, so from the different consumer group, these consumer can read the topic A partition 0, partition 1, but different partition even from this consumer as well. So this is how the configuration in works in the Apache Kafka. So let's understand deeper. So in the previous slide we have seen the this particular the broker. So in the broker we'll have a multiple topics, and within the topic we have a partition, and this partition will be subscribed by the consumer, and the group of consumer we call as a consumer group, right? So these things we know now. And so multiple brokers, right? So we have a broker 1, broker 2, it will form a cluster, right? Apache Kafka cluster, and this cluster will be managed by the zookeeper. Now let's understand how the basically the message will be delivered from producer to the consumer. So whenever the message will be pushed, right, so that will have a topic name and the key it will be defined. So suppose the topic name will be A and the key will be 1 2 3, then the key will be hash. There will hashing will be performed for the key to identify the which partition this message will go. Suppose the hash key will return 0, then this message will be going to this partition. And whoever the consumer will be subscribed to this partition will read the message according to the offset. So from the offset 0, this consumer one will read the message. And suppose if the key is not defined, then what will happen? The Kafka will use the round robin fashion to assign the messages in the partition, because we know the topic name. So we know the topic name is A. So message will come to topic A, but to which partition it will go? It will perform the round robin way. So first message will go to the partition 0, second message will go to the partition 1, and third message will go to again partition 0. Key is not defined. The Kafka will follow the round robin way to push the messages into the partition, and from the partition the consumer will read the message by with the help of offset, right? So this is the how the message will be passed from the producer to the consumer and it will be consumed. Now let's talk about the broker, right? So we have three brokers. So basically three machines which is running the Apache Kafka, right? And it will be managed by the zookeeper. So whenever we create a topic, right, we have to define the replication factor. It means how many copies we want for that particular topic. So suppose we define the replication factor as 1, and when we created a topic A, it will create one more topic for A dash. It's a kind of one will be the leader and second will be the follower, and any messages will be arrives that will be comes to a leader, and the message will be read from the leader itself, and those messages will be synced to the follower. So here I have defined the topic A will have a replica in broker 2, broker 2 will have a topic B leader and its replica will be in the broker 3 and will have a topic B. Like that the message will be stored and synced in the different broker. So what are the benefits we will get? Suppose if the broker 1 goes down, then we'll still have a message in the broker 2 and this follower will become leader and it will receive the message in place of topic A, and the message will be read by the consumer from this topic A. This ensures that if goes down, data will not be lost. If the failure happens to the leader, follower will become the leader. Now let's talk about the consumer group, right? So basically a group of consumer is called a consumer group, right? Whenever the producer pushes the message, right? So suppose the message is pushed for a topic A, and whatever the key is defined, according to that the hash will generate it as the 0, so message will be pushed here. So what happens whenever the consumer read the message from topics, right, from that particular partition, that the consumer will commit the offset whatever the message he is read from that particular topic and the partition. So zookeeper will maintain those entries. Suppose it read the partition entry offset 0, then 0 will be updated by the zookeeper. So it will also keep track of the consumer group ID, topic name, partition ID, consumer ID, broker ID, everything he keep track. Suppose one more message comes, consumer will read that message also. That will be committed offset will be changed to 1. And suppose if the consumer is 1 is goes down, right? Then what will happen? Then the consumer too can start the reading the message from the topic A partition 1. But how he will get to know from where to read? He can check the committed offset, that is 1. So it means the message is read till 1. So he can continue the reading the message from offset 2. This is how in case the consumer goes down, another consumer can continue from the committed offset, right? And suppose if there is a processing failed by the consumer, suppose the consumer is read that particular message, right, and that it got failed, it returned acknowledgement from the consumer to it is the failed, right? So what will happen in this case? A consumer to again try to read the message from that particular offset, right? It is reading from first time as 1 from this particular offset 2, then second time also is reading the offset from try offset 2, then third time also reading the offset. We can configure the retry, right? Number of retry till what time the consumer can retry. So we can configure like that. So whenever the consumer read the message, it can keep the number of retry as well. So first time the retry will count will be 1, second time retry count will be 2, third time retry count will be 3. Then after that, that particular message, once the retry is exhausted, that particular message will be moved to the topic dead letter. So it's a kind of a dead letter queue, whatever we have seen in the RabbitMQ. So similar kind of a topic dead letter we have. So in that, message will be pushed from partition 0 to here. So message will be pushed from partition 1 to the dead letter queue. And this is how the failure and retry will be handled. So and later point of time from this topic dead letter, right, and the even from in the rabbit MQ dead letter queue, this particular queue partition can be subscribed to a particular consumer group of consumer, right, and from that it can be analyzed, right, what is the failure happening and what is wrong with that message particular, those things we can do that. So now let's talk about what is the difference between the RabbitMQ and Kafka, right? So basically the RabbitMQ is push based. The queue will push the message to the consumer. So same thing I have written here. The message will be pushed to the queue to the consumer, and we can call as a smart broker because that is the broker is pushing the message to the consumer, right? And we can say the dumb consumer because consumer is getting the message. And topology, we have a different type of exchange. So fan out, direct, topics. These are different kind of exchange we have in the RabbitMQ. And in Kafka, it is kind of a pull-based mechanism because the consumer has to pull the messages from the partitions, right, according to the offset. And that's why here I have mentioned it's a pull-based mechanism because the message needs to be pulled from the topic on the particular partition and the offset. And broker is dumb because that is not pushing the message to the consumer, and consumer is smart because he is able to push the message, right, he is able to retrieve the message. And in the topology where it's a kind of a publisher subscriber kind of a topology. So this is all about the messaging. So thank you for watching my video. So please do subscribe my channel to get to know more about the system design topics.